Hey, welcome. This is the Boston.NET Architecture Group. My name is Robert Hurlbut, and really glad that you're able to join us tonight. Tonight, we have a very, very special presentation from Rupen Anjaria. This is special in the sense that it's a little different in terms of a presentation where there are no slides. It's just source code and showing about some of the code constructs and new things that are happening with .NET 9 and C# 13, and just some things that Rupen has been finding out and learning about and sharing with our group here. So without further ado, I'm just going to turn it over to Rupen. So Rupen, thank you for joining us. Thank you for presenting, and really appreciate it.
Oh, no, thank you. Thanks for having me, actually. Uh, it was very short notice, but I'm glad we made all the arrangement. So thanks for that. So, yeah, so before I start, uh, I'm sharing some Visual Studio code here, Visual Studio itself. And on my machine, I have installed this .NET 9 framework, but just installing this will not enable you to try these features. So let me quickly share what I did. So if we, after installing in Visual Studio, we have to go to Tools, Options. And in that we have Preview feature. And in that we have to enable this Use Preview feature. And after we starting Visual Studio, you should be able to start, let's say if I'm creating a console project, and this is default, but then only you will be able to see preview version here. You may be aware, I'm just sharing it. And the second thing is that in project file, we have to enable this language version preview to try some of the C# features. And I will go over this extension when we'll reach the specific feature. So with that, let me show what I have here. You can ignore this. You see, I have a class called student, and it has a like name, major, and P. And in program main, I'm just creating a list of students. So the feature that in .NET 9 we are going to discuss, I have categorized them. So first category is in LINQ. So you may be aware that LINQ stand for Language Integrated Query, and we usually use it for querying very different kind of data sources. The good thing is that syntax is common, and you can query lots of different type of structures. And it's not that for performance, but it's more for our code readability. So let's say in this list, we have a requirement where we would like to see that how many students are there in, let's say, maths, how many are in physics, chemistry, or maybe biology. So let's say we would like to generate a list. So essentially it is just grouping by major, but in .NET 8, what we could do is that we'll write like, say major count, and we'll say students dot, we'll say first we'll do group by, and say as major is the subject, will be grouping, and then we'll do select, and in select I can say as, and then we'll be creating a kind of anonymous type with the field as measure, and that measure will be our student dot group. I mean, it will be student dot key, because group by is giving us key value pair, and then you can say count as dot count. So this is what we do normally in .NET. Maybe you can just reformat this so we have readability. So once we get this, it is basically a list of major and count anonymous object. And then we'll write for each loop, which will loop through this. And let's say so dot write line. In here, I can write okay. And if we run this, don't know why it's so slow. So you can see that this is like we are getting like there are 4 students in maths and three in physics, chemistry, and 1 in biology. So this is what we normally do in .NET 8 method, but I'm going to show you something new in .NET 9. So in that we don't need to create this separate object. We can directly leverage in the method directly in for each. So let's say they were student in and students dot, and what they have is count by. And here we can give the key that we want. So in this case, it's measure. And when we loop through, we can just use a student object. And you can say it says group count by will give you key value pair. As you can see, its return type is key value. So in this case, this will become our uh, value because it gives you count, and this will become our key. So let me just comment this and block. Now if we run, so as you can see, we have like accurate count, and this also looks much readable compared to what we have been doing for .NET 8. So that's a count by new method. Another method that they have is, let's say, from this list itself, we would like to see which subject has highest number of students, right? So that we can do using, let's say, max student equal to, you can write students dot count by, and I can say measure. And after that, you can use new method that is max by. And again, here we can give key that we want to max by what. So since this is we're getting measure from group by, so we'll normally go with key value, right? So value will become our count, and this will become kind of key. So, and max by will always give you key value pair, single instance of key value instead of iterable. So when you want to print this, you can just write that there are, say, not there, but commenting. So we can see that it's showing most students choose the, so 4 is basically our count and math is subject. So maybe I just change the value. So it was actually key and value. That will make it more readable. So that we can get in just one line using a new method. Similarly, we also have new method in LINQ that's min by, and what essentially it will give is that just opposite to max, it will give us a subject for which less students have selected. So if you run it, it should give us a biology and there is only one. So these two method, then let me share one more. So let's say the requirement is that we have this list of students and the fees that they have paid. But let's say the requirement is to get the total fees that was paid for maths or maybe for like physics or chemistry. Basically, we want to group by, but we also would like to take the sum of fees that was paid. Okay. So in order to do that, what we can use is a new method. It's called aggregate by. So it's sum fees equal to students dot and you can say aggregate by. And the first argument it will take is the key on which we would like to perform the grouping. So in this case, it's s dot major. The second argument is let's say seed, which definitely will be 0. And third argument is a function that we would like to run for each group. So let's say like total and then student such that student dot p, and that's about it. So again, this aggregate by will give us a key value pair. So we can iterate over this. So for each where turned in some fees, and we can write a line. It's student e. Okay, so once we have this, let's so what we have here is so for it's actually grouping and it's adding the fees that we have. So you can say for math is 80, physics is 30, and so on. So this is one more, I think, very useful method that we can use in .NET 9. So the next,
Rupin, before you
yeah,
go too much further, we have a question about the other example before this related to the min by, max by type of thing.
yeah,
So right now you have, let's say the max by, you had you had four maths. What if you had one more chemistry? So then you have four maths, four chemistry. How would that work in terms of results? I'm just curious.
yeah. I believe that it is taking the order. I mean, oh, so you're saying that maybe for max by there are multiple max value.
Right. But the
Yeah,
same. So if you went back up
yeah,
to your list and added another, chemistry, I noticed you had three chemistry.
yeah. So I think maths is the highest. So if you say max, yeah, you're saying that we can one
Yeah,
or
just
more.
add one more chemistry. And then we can
Yeah,
comment, you can comment it out after just because I know it's skewing us a little bit. But yeah, just curious. What does that do?
yeah. So I believe that yeah. Let me. But this will make like math and chemistry same, right? So we'll see what who is it is picking up.
Right. Okay. So I just
Yeah,
fix the first one. Okay.
fix the first one. Maybe we can do some ordering before we even do that. So let's say for major, we can do the ordering by subject. But I believe that if there are multiple reasons, then it's picking the whatever coming the first one.
Right.
If we don't give any order, then
Right. Okay. Thank you.
Looks like there's an overload that takes a comparer. I guess you could use that.
for MaxPy.
Yes.
Oh yeah, we have to implement that interface, right? iComparer. Yeah.
Yeah, I mean, unless it's something that already does implement comparer, but in student case, yeah. Yep.
Yeah, this is like, when we do let's say we do search in an array, right? And we want to ignore the case, right? So we usually implement the interface in that and pass that method for the comparison. So something not it is doing out of the box, but we have to implement program for that if you want custom comparison. Yeah, so that's about the link method. So yeah, so the one more method is that is when let's say we have a list, right? We show the aggregate by. So let's say we have this list and we just want to iterate. At the same time, we also want to know the index of each student. So it's a 0 for Steve, 1 for Bob, 2 for David, something like that. So what we normally do in .NET is that we can for each, and here we can. This is very uh, different syntax. That's value and index. I would say in you can say students dot, and then we will select because that gives us index. And here we can write index comma value, and then just give me index comma value. So, and then we can write console dot write line. And I'm just writing here that index is p dot name maybe. Yeah. So if I run this, so we can see that we have index for each of the entry, but still compared to uh, what we are achieving, this way is very difficult syntax to remember. So what we can do in .NET 9 is that they have a new method, and we can just say it is like it's taking index and value first in students dot, and we can just write index. And you can just copy paste this. Yeah, so we have the same output, but I believe that you'll agree that this compared to what we do for students and I mean selection and this compared to that index is really helpful when we need index for each entry. So yeah, these are the new method that we have in .NET 9 for LinkU. So the next feature that I'm going to discuss is something in that we usually do for searching. Let me remove this. So in .NET 8, we have a method, we have a class called search value. And we use that search value when we want to perform search in array or maybe byte, right? So let me show an example here. So let's say we have character array. A. And if you want to, let's say this is very small, but let's say we have a huge chunk of array and we would like to see whether particular character is there or not. You can say console dot write line, and you can use native method, like whether it contains or not a particular element. So if we run this, it will say true. But like we discussed it, if we contain capital C, then it will not return because this is not a case insensitive. So it is saying false. And if you want to do, I think you have to implement some. We cannot do it for char, but yeah, for string we can definitely pass some second argument, which will, yeah, we can high equality comparer. So this is its native method, but let's say we want to use search value, then we can do search values equal to, and we have to give type create, and here I can do char array, and we can just, so again, as we have native method that contains, so this will return the whether C is there or not. So I can say it is true. So this is something not new in .NET 9. I mean, yeah, .NET, and this is search value is already there in .NET 8. But starting from .NET 9, what we have is we have a new type. It is string. This will be supported in search value. So far it's just char and byte. Now we have string in search value. So let's say if I have a string array here, I'm just bringing from the solution. And if you want to perform a search, we can do similar way, like search values sv string equal to create, and you can pass the source string. And as a second argument, we can put a string comparison type that we would like to ignore the case. So not string comparer. Wait, it's not working. Oh yeah, I have to give string here because now I'm supporting string. So this will perform string search, and we can say console. We can say string dot contains, and so that gives true, and you can see that it is actually case, and you can ignore the case. So you can type brown here, and if you run it, it should still give us true. So this is basically a string comparison method that we can perform in .NET 9. So this may look different because already we have native method for string. So we can also do this in native method, but this will be, for now, this will be case sensitive. So I'm saying it brown. Now this should also give me true. But here, let me show you one more thing in search. So the search value, when we create it, what C# is doing is that it's checking the source string on which search will be performed. And it also checks what kind of machine, or rather what kind of processor we have. So compiler will detect all the environment on which the program is running. And based on that, it will calculate what method will be most suitable to perform the faster search. So it is more like so it will definitely perform faster than native. So let's say if we can, the best way is to do benchmarking, but I'm using stopwatch here. So let's say we have stopwatch SW, go to new stopwatch, and I'm just starting here. And after performing search, I can say stop, and I can just write line. So I can say native search group. I'm just elliptics and putting a 1000 separator. So this will, instead of putting like this, it will put 1000 separator here. I mean, we'll put comma so we can read it properly. And then I can say sw dot reset. Now I'm doing another search using search value. So I can say sw dot start again, and say sw dot stop. And so now if you run, let's comment this. So you can see the difference, like it's 563,000, while the search value just took 3,000. So there's a huge difference in the way search has been performed. But at the same time, yeah, I mean, it's like pay once and gain more. So let's say search value creation, that takes more time. So if I start before I create it, so now my time is not calculated just for search, but it's also calculating how long it took to create the search value. So if we run, and then you will see that, so this 155. So the time has increased definitely, but it is still much faster than a native search that we are doing. So I believe that search value with string will be helpful if we are performing so much search on a single string array basically. So this is something new in .NET 9 for search value. So the next thing that we have is async await, that they have new method. Let me just delete this. And since I'm doing this demo in program static, I'm putting some ad hoc method. So let's say we have a method called static task, and that gives us a string. And I can say similar delay, and I can say int delay and string task. Okay. And here I can say, yeah, task, and I'm just returning task name. So let's say we have this method which we are actually delaying. We are purposely delaying and returning string. Nothing that fancy, but we would like to call this in an array of object. But let's since I'm running this in a array, so let's say we have function for static async task, and I'm just creating a function that run task async, and this function in that function I'm creating a list of tasks. Okay, and that task is actually giving string, and as a task equal to an array, and in that I'm just calling this simulate delay with different value. So let's say first one is taking 4,000, and I'm just taking task one. Now fourth task is I'm simulating such that task one takes longer, and two and like subsequently task four is the fastest task in this list. And let's say we want to run this task in asynchronous way. So I'm just copying some stuff here because this is under program. So now let's say if you want to run this together. So what we have been doing is that where output equal to task dot, and we can use the method that normally we use when say when on. Okay, on, and here I can give task. So this will basically wait for all the tasks to be complete, and then only it will free up the thread. So this output will be, let's say we loop through for each string output. Okay. And we can say just so if we run this, yeah, so you see that all the output came in just just a moment, even though we set up delay for them separately. Right? So let's say this is good for some scenario where we really want to wait for all the tasks to be completed. But we may have a scenario where we don't want to kind of wait for all of them to be finished. We may want to get the result as soon as any one of them is done. So the way we do in .NET 8 is we can actually use this way. So we can say task dot any, which will give us a true, even if it has one, as long as it has one element. So we'll loop through this list basically, and we can use finish task equal to uh, task dot, and we use this when any, and I can give task. Okay, and yeah, we also have to make sure that we remove tasks dot remove the finish task, otherwise it will be an infinite loop. And we have to use here We can also write here. We should also await. So now if we run, and you can see it is returning fourth task first, and then third and second and first one, because we had set up delay such way so that we know that task 4 will be finished earlier than task 1. So this is still good, but we, as you can see, we have to manually maintain the list of tasks, and we may have to make sure remove, and it's still a lot of work we are doing here, right? So we can do this in simple way in .NET 9 is that, let's say we await for each, and you can have task in, now you can say task dot, and we have a new method called when each, and here I can give the array of task. Okay, and I can say console.writeLine, and you can say await. I'm just commenting this. Run this. Yeah, so we have very similar output, but at the same time, you can see we have very less code for this, and we don't have to maintain. Yeah, internally, .NET is definitely maintaining it, doing it for us, but it is more readable and easy to maintain. So this is the new method that we have in .NET 9, and I'm sure it will be useful. So let me comment this. So yeah, the next thing that we have is something in related to caching. So we all know, right? Uh, those who don't know, let's say in our application, we have a requirement where we need to bring data from database, or maybe we are calling another API and bringing result from there. So those kind of thing is require some kind of caching implementation. If those values don't change so often, so maybe we have some configuration in database, or the API is returning, which is not that dynamic. It may be there for all day, it doesn't change. So to overcome, what we normally do is that we implement caching. And let's say we have a server and we use a memory cache. So what memory cache will do is that, let me share with um, in a diagram. So let's say our .NET application have a memory cache implemented, and whenever request comes in, it will check whether the cache key has some data in our memory cache or not. Okay, if it is there, and then it will return the data that we have. If it is not there, then it will get the data from the data source and put it in a memory cache, and then it will return the value, right? So that is really nice and a faster way, but it has a limitation that when we have multiple servers running, and each server have their own memory, right? So because this is in process, so if we restart our machine or even recycle the app pool, all the data we had in memory, that will be gone. So we may experience a slowness for the first time again. So that's a limitation with a memory cache. So what we normally do is that we have multiple server, and in that case, if each server has their own memory and every version is different, it can be different because we change value in database or configuration that got refreshed in one server, but another server may be returning from the memory. So in that case, user may get different data. So to overcome, what we normally do is that we employ a distribution case where we have load balancer, and we can have one caching server. So all the server can go to the caching server and bring the result. So it becomes single source of caching. Maybe we can use Redis or SQL Server for storing our cache and retrieval. So, but again, in both of the case, memory cache and even distributed cache, there are chances that that can actually crash the application, and that's something called cache stampede. So let's say we have some data in cache and it's set to expire in, let's say, 10 minutes. So just it expires, and right at after the 10 minutes, let's say we have lots of requests coming in. Since we don't have anything in cache, this all requests can actually go to your resource together, and they can all try to bring this, and they can all try to put it in your memory cache. So that's something called cache stampede, and that can happen in both. It's just not memory cache; it can also happen in our distributed cache. So to address this, what .NET 9 is there something called hybrid cache. So I have a class here. I'm just showing that this is the cache key we'll be using to store and retrieve the particular cache value. And we are here implementing interface for iMemory cache and iDistribution cache. But if you see hybrid cache, it is actually a class. And I believe the reason is that Microsoft would like to more control the implementation of what should be done in hybrid case, and I think you'll be convinced when we'll see how it is done. So in this, let's say we are initiating this interfaces, and this function is just our normal, which will bring the data. I'm just simulating delay, but there is no cache involved. And like this is a function, so it will actually call the data without any caching. But let's say we implement memory cache. So what we are going to do is that we are actually first checking in the memory, bring a value for cache key, okay, and store it in data. And if you are not able to find, then go to the actual data and bring it up, and then store it in a memory cache, and then return it. Right. So, and this is still good, but it you can see it has lots of if and else and checks and around here. Same way for distribution cache, it is checking differently, but it doing the same thing. It's checking. If it is null, then actually go and bring from the resource, and again set in the distribution, and then you return it. But when it comes to hybrid cache, uh, you can see that it has a built-in method called get or create async. So that way we are eliminating the need for checks and setting and all these things. And the first argument is cache key. If there is nothing for cache key, then it will evaluate this lambda expression, which will actually do and get the data from the resource. And the third one is cancellation token is default for now. So you can see that compared to memory and distribution, this is very simple, and we don't have to maintain this caching stuff. The other thing about hybrid is it has internally it has two layer, primary and secondary. So primary is your memory cache, and secondary, if you implement, you can also have distributed cache. And hybrid cache will internally maintain both of them. So whenever request comes in, it will check in primary. If data is not there in primary, then it will go secondary. And if it is not in any of them, then only it will go and get the data from the source. And it also has a built-in cache stampede protection, which neither of them is providing. So, and like its name suggests, it's using both memory and hybrid distribution. And it can actually magically detect that since you are implementing distribution cache, so it will set up that as your secondary cache. So I believe that this is again one more plus for going for .NET 9 and using the hybrid cache. So that was about hybrid. So this all that feature that I discussed so far are for .NET 9, .NET 9. That means this is available in VB.NET, C Sharp, and F Sharp even. But the next two of the things that I'm going to discuss is only for C Sharp 13, right? So the first thing that I would like to discuss in C Sharp 13 is something related to param. So basically we use param when we have a function, and that function has a, let's say let's say we have a function here called int some numbers, and I can say int a, int b, and you can return this addition, right? So let's say we need one more variable, then we can say int c and so on. But let's say we have lots of value to pass for integer. What we can do normally is integer array, int array of type, and maybe we can say numbers and numbers dot sum. As we can use this way. So we can call this, say, where x equal to some numbers, and I can pass array like 1, 2, and 3. So if we, I'm just commenting this stuff. Yeah, so it gives the result. But let's say we want to pass comma separated value. So if we use here params, we can actually pass comma separated value, right? So what params is doing is that it is converting comma separated value into int array, and that's actually it gives more flexibility, because not only int, you can also have your list of int as a receive, and you can still you have the same function. You are not change anything, but you can change the type here. So this is because the params will do the conversion from comma separate value to whatever type you have defined. So from .NET 9 onwards, what we can have is that so far params is only working for array. So you can have string or char or array or integer array, but you cannot have enumerable like list or even your custom class. You cannot have that with params. So from .NET 9 onwards, you can do that. So that's a big change for that. And the real benefit you will see when I'll show, let me show some more demo here. So let's say we have this function and I'm calling it. But let's say I am writing another function, say some numbers, and I can say span. And what it takes is params, and I can say read only span. Okay, I can say int and number. And since it's a param, it's not an integer, so it doesn't have built-in method. So I can say int sum equal to 0. And for each numbers, I can say sum, return sum. And now I can almost call the same method by y. So here I have two methods basically. One is params with read-only span, and another is param with int. And I'm just calling this console here. Let me just group them, or maybe this is fine. And if we run, you will see that it is working. Yeah, both are giving 6. But let
You
me show
forgot to
with,
change line 104. You forgot to change the method you're calling.
sorry.
Line 104, you forgot to change it to set number span.
Oh, I'm really sorry for that. Yeah. Yeah, thanks. Thanks for catching this. Yeah, so now you can see that it still work because see, even if I had some numbers and I change the function name, it is params is just handling this. So even though it has comma separated value, it is internally converting it into read-only span. So we can still run and we can check the output. So the real benefit params combined with read-only span is that it's speed, right? So let's say we do some more benchmarking, not real benchmarking, but if I use stopwatch, so stopwatch SW equal to new stopwatch, and it's a start. Now we can do the same for when we do the calculation using this. I can say oh, I just have to reset. So basically what we are doing is that I'm calling this and I'm benchmarking using stopwatch. So we do this. Yeah, so you can see that there's a huge difference between integer array and read-only span. And yeah, definitely, even though we are doing our own looping and all the calculation, behind the scene, even this implementation is doing the same thing. But ours is faster because we are using read-only span. And yeah, the good thing with Param is that it's just not read only. We can also use our custom class. So let's say I have a class here, okay, my numbers, and I'm implementing it to the interface IEnurable, and I'm doing all the method here, necessary thing for implementation. I can actually call this type in when I convert using params, and you can see it just work. I mean, even this is working. That's because all the magic is done by the parent. So yeah, just to conclude, parents with read-only span is really good thing when we want to do some iteration with numbers and dumb calculation with that. So that's something in related to parents. So the next thing is not a big change. It's about collection access. So let's say we have int error equal to, I'm just putting some, let's say some numbers here, 1, 2, right? And if I want to access, let's say console dot write line, Let's say if I want to access the last element, so what we'll normally do is that arr.length, and we'll do -1 because we want to get the third one. So get the total and -1. So it should give 3. So C# 9 have introduced an operator to access the last element, and that is you can do using this and first. It's not a 0. So from last, give me the first one. So if we run this, it should give the same output, 3. And yeah, likewise, you can like maybe from last, give me second one, which will give you 2, and so on. And not only that, you can also use this last operator to even access. So I can write like int array and arr2 equal to new int array. And if I'm giving, say, its length, and I can just say arr2, and I can even start assigning from last one, likewise. So you can do in a reverse order that we used to do. So that is about collection access, something new. And yeah, the last one that I have is something about called semi-auto property. So that I would like to show you in SharpLab because it's I would like to show the compiler generated code. So let's say we have this SharpLab IO, and where I'm using this semi-auto property. So let's say in .NET 8, what we usually do is using just, I don't know what's wrong. So, and let's say if we have a class or employee, and in that we have a property. I'm using auto property here. So let's say it's public int age. So the moment we declare this property, you can see in compiler generated code. Oh, this is not. I'm not accessing get set. Yeah, so this will make it auto property. And you can see in compiler that it is creating a property, I mean property accessor, but it is also creating its own backing field, which will be used to store and to retrieve the method. So this is good, but let's say in .NET 8, we would like to perform validation that whenever we assign some value to age, it should be always greater than 18. Now, if we cannot do this using auto property, so what we'll do is that we'll use employee, let's say an 8, because I'm showing .NET 8 version. We will create our own backing field, and then we'll create our property accessor. And in that, we will kind of implement what we should do. So let's say for get, we are returning underscore age, and for set, okay, we can do the validation that if value is less than 18, then you can say throw out of range. You can just put some message. And then if it is passes the validation, then we can say age equal to value. Right, so this is what normally we do in .NET 8. What's wrong here? Should keep this. So .NET 8, if you see compiler generated, there's actually no change because we have created our own backing field and our property accessor looks very same to it. So this is good in .NET 8, but from .NET 9, what we can do is that we have they have provided something called accessor. So using that, you can actually access the backing field that it is generating for you. So let's say we want to write the same class in .NET 9. We'll say class and employee 9, and I here let's say I'm writing public int age. This is essentially I'm writing a property accessor without declaring any my own backing field. And here, let's say if I want to get, I'll say now here you can access the backing field using field keyword. So this will enable you to access the backing field that compiler will generate for you. The rest will be same. So let's say for set, I can use the same validation that I gave here for the value. It's just here instead of age, you can use field. So and you can see that even when it compiler is generating, since we didn't declare any backing field, it is creating on its own. And you'll not see the field here, but it is already provided here in this, and you can use it to access it. So this is to facilitate. Let's say this may be small class, but let's say we have class with lots of backing field, our own private field. There is always chance that we have another method that can change the value of this. So in this case, if we have .NET 9, you can use just create property accessor and use field to access the backing field. And so far, what they're saying is that you can, let's say in .NET 8, you already have a backing field called field, because that can happen, right? So let's say maybe I can say class test, and here I already have a private int field, okay, and I also have public int field as its a property accessor, where I am, when you say get, I'm giving you field, and set. For now, I'm not doing any validation, but I can say field equal to value, right? So let's say we already have this in our .NET 8 and we are upgrading it. What I know so far is that there will be some kind of tooling will be provided which will detect and say that, hey, you are using field. Now from .NET 9, it's a kind of keyword, and this keyword is only valid within the properties. Like it's not a you cannot create a class or something like that. It is only in the property accessor. So it will still work. Your code still work. Like you can see here, there is no issue with that. But just to know that you are using your own field, you can actually decorate this in the property accessor with @. So it will just tell you that this field refers to your own backing field and not the field that is generated by C# compiler. So yeah, I think that is something in the semi-auto property. This all changes may look like maybe saving one line or two lines, but if you see large scale enterprise application where there are 1,000 lines of code, this can actually literally save around out of 1,000 you'll be having at least 800 lines. So 200 or something around you can definitely save. So and guess what, our output will not change because as you can see there is literally no change in the way the output has been generated. So I strongly suggest that we you have this thing, and try .NET 9 its feature and see where you can change your code. Yeah, so I have only this. If you any question, let me know.
Okay. Yeah, I don't see any particular questions. But yeah, anybody have a question? Come off mute. I have a question about SharpLab. I've not used that. You're trying out. It looks like C Sharp. Is this all C Sharp?
No, you can definitely use this other languages,
Right,
but
but I
this.
mean, in terms of versioning, how is it? How's it know what version you're using or trying to show?
Oh
Like,
yeah, this using this branches they have.
oh,
So it,
okay,
yeah,
okay,
that's the reason I specifically picked this semi-auto, because I wanted to make sure that in my SharpLab I have this feature available.
got it. Okay, very cool. All right. Any questions? Any other questions?
Yeah, this is John Cassidy. Rupen, that was very good. I appreciate you taking the time for this.
Oh yeah,
I had a question about the hybrid.
caching.
Yeah, caching. Will they be making any other modifications to that in the future, you think? Because I saw it, I didn't follow up on it yet.
So they are actually, yeah, sorry, go ahead.
It includes both the managed and the
Yeah, so
memory and
so
distributed.
yeah, they both will be in, I mean, primary and secondary both will be, it can handle. So basically this is it's called hybrid. I believe this is because it's combination of both memory and distributed cache. And uh, like you may be wondering like how do you know? Because in this implementation, I didn't specify anything about distribution. Memory is still fine, but distribution. So what I know is that it magically detects that you are implementing this interface in your program. So it can, from that, it can infer that you have distributed cache setup. So it will be using that as a secondary.
Okay.
Okay. Any other questions? Yeah, absolutely. Yeah, thank you. Some comments coming in. Thank you for this presentation. Really, really fantastic. Rupen, and so for everyone, we'll be making this available on our on a YouTube channel. I'll post the link to it once it's uploaded and everything. It'll be out in the comments. We'll also share on our Slack channel as well. For some of you that are new that would like to join our Slack channel, I'll send out a link as well. It's been a little while. I'll send out an invite if anybody would like to join it. Do we have a question?
Thank you.
Yes, I have a question.
Sure.
I was wondering if with the recent changes of C Sharp and .NET, or C Sharp 13 and .NET 9, was the goal? Sorry for my stuttering, but was the goal to make it easier or more efficient for people who just started C Sharp, to make it easier for them to code in C Sharp?
Yeah, so I guess what you're asking is that, I mean, it is in a way, yeah, in a way it is that the goal. Because if you see some of the example that I showed, I mean, it goes with lots of assumption that when you want to let's say, get the index of a link queue object, or you want to do some maybe count by or something like that. It is you to go and actually learn somewhat more in link queue. But if you know the count by method, it becomes easy. So in a way, I can say that the ultimate goal is to reduce the number of lines that we write. I mean, so we can write less and do more in that. But definitely, we can say that it becomes easy to learn, because when you're new, you may not be aware of what was the earlier method, and there is no need to know, and you can just learn the new method and you can be fast in that.
Okay, thank you.
Yeah.
Okay. All right.
And
Well,
yes,
oh, go ahead,
sorry.
sir. Please.
Rick, I'll be definitely, I can share something in GitLab. I can put all the code that I have shown. I can generate separate solution. I can put it in GitHub and I can share the link.
That would be fantastic. Yes. If
Yeah.
you do that, we'll definitely share that link, or you can share the link in the comments. Either one would be great. Appreciate it.
Yeah, sure.
Okay. All right. We'll stop the recording.